In this video, we will do an introduction to inverse functions. Welcome back to my channel, Numerics with Nadia, and let's get into our lesson objectives for today. By the end of this lesson, you guys should be able to define what an inverse function is, identify when a function has an inverse, find the inverse of a function algebraically, and check if two functions are inverses of each other. So down here on our graph, we have an example of two functions that are inverses of each other. As we go through our lesson and go through and define some terms and do some practice, you guys will be able to understand it more, but there's just a little visual example. Now let's get into some vocabulary and key definitions for today. First off, we have a function. A function is a rule that assigns exactly one output for each input. Next, we have an inverse function. An inverse function is one that undoes another function or reverses it. So if f of x equals y, then the inverse of f of y would equal x. So the inverse of a function is noted as f to the negative 1 power. That's a little notation. Our next term is a one-to-one function. A one-to-one function is a function where each input maps to a unique output and vice versa. Only these functions have inverses that are also functions. And our last term is a reflection line. A reflection line is the line y equals x. A function and its inverse are mirror images across this line. And that is that little visual that we saw on our last page. So go ahead and write these vocab words in your notebook, and now we'll move on to the steps to find the inverse of a function. It is 4 simple steps. First, we're going to start with our function, and instead of it being f of x equals, we're going to write it as a y equals. Then for step 2, we're going to swap x and y. We do this because this reverses the roles of input and output. Then our third step is we solve for y, and our last step is that we're going to rewrite it in an inverse notation. So we'd rewrite it as the inverse of f of x. And those are our 4 steps. Now that we have those written down in our notebooks, we can move on to our first example for today. And for our first example, we have a linear function. And for number 1, our example says to find the inverse of the function f of x equals 2x plus 3. So our first step is to write this as a y equals. So we'll write that f of x equals 2x plus 3 as a y equals. So we have y equals 2x plus 3. Our next step is that we're going to swap. So we're going to swap our x and our y. So we'll rewrite this as x equals 2y plus 3. And once we do that, we'll go ahead and solve for y again. And when we do that, the algebra here, we would subtract 3 from both sides and then divide by 2. And when we do that, we end up getting that y equals x minus 3 over 2. And our last step is that we have to rewrite this. So we would rewrite this as the inverse of f of x equals x minus 3 over 2. Now that is going through and doing the 4 steps to finding our inverse function. I also want to show you guys visually what this looks like. So our red line is y equals 2x plus 3, and our inverse is x minus 3 over 2. And notice how they are reverses of each other. So now we'll move on to our second example. For number 2, we're going to have a simple rational function, and we are being asked to find the inverse of f of x equals x plus 1 over 3. So our first step is that we're going to write this as a y equals instead of f of x. So we will write this as y equals x plus 1 over 3. And then our second step is going to be to swap the x and y. So we will rewrite this when we swap as x equals y plus 1 over 3. Next, we're going to solve for y. So when we solve for y, we are going to multiply by 3 on both sides. That gives us 3x equals y plus 1. And then we'll subtract 1 on both sides. So that'll give us y equals 3x minus 1. And our last step is going to be to rewrite this in the inverse function notation. So we will have the inverse of f of x equals 3x minus 1. And again, visually, our graph here in purple, we have y equals 3x minus 1. And then our green line is our inverse. And see how these are inverses of each other. They are reverses of each other and they intersect. Our third example is one of quadratic restriction. We are being asked to find the inverse of f of x equals x squared, with the domain being restricted to only x values greater than or equal to 0. So first off, we're going to rewrite this as a y equals, so we have y equals x squared. Then we're going to swap our x and our y, so we'll have x equals y squared. And then we're going to go through here and solve for y. So we do that by taking the square root on both sides. When we take the square root on both sides, we will get that y equals the square root of x. Why? This is only because our domain was restricted. So since our x values are going to be greater than or equal to 0, this function will exist. So we have y equals the square root of x, and then we have to rewrite this in the inverse notation, which would be that the inverse of f of x equals the square root of x. So this is one of my favorite visuals here because you can clearly see the symmetry and the reversal since they are inverses, and it almost forms like a little ribbon looking graph. So that is our third example, and now we move on to our fourth and final example for today. And this is going to be how to check if two functions are inverses of each other. So we're being asked here, are f of x equals 3x minus 2 and g of x equals x plus 2 over 3 inverses? So how do we check this? We're going to do two things, and they both need to equal x for this to be true. We're going to check what f of g of x is and what g of f of x is. This sounds kind of crazy, but just stay with me. So we're going to plug in g of x into the f of x function. So where we see x, we're going to plug in g of x. So we'll have 3 times x plus 2 minus 3 minus 2. When we go through here and simplify, we'd get x plus 2 minus 2. The 2's will cancel out, and we get x. So that is perfect. Now we have to do the inverse. So we'll do g of f of x. For g of f of x, we'll go ahead and start with our g function and plug in f of x where we see the x term. So we'll have 3x minus 2 plus 2 divided by 3. Our 2's will cancel out, then we're left with 3x divided by 3, and our 3's cancel out, so that leaves us with x. So this one equals x, our previous check equals x. Since both of them equal x, that means that the functions are indeed inverses of each other. So that wraps up our final example question for today. I hope you guys enjoyed this video. Please feel free to like it if you did, comment any questions or any other video topics you would like to see down below. Please subscribe if you haven't already. Share this video with a friend, and I will see you guys next time.